So we're going to talk about exponential and logarithmic equations part B today. Here are our main objectives, which is very similar to what we've done yesterday. So we're going to do example 1, but in this case, we have to use logarithms to solve this. Notice how yesterday we had something called the same base. This base is 5, this base is 3. They are not the same as each other. So let me put this here. So base is 5, base is 3. Therefore, we can't put the exponents equal to each other. So what we have to do is we're going to apply or take the log or natural log to both sides. So I just write down log of this side and log of the other side. So I'm going to take the log of this 5 to the y plus 3 is equal to log of 3. Now the nice thing is that we can now use the power rule to bring that out of the exponent. So we're going to have this y plus 3, and we need to keep that in parentheses. And that is multiplying times this log of 5, and that's equal to the log of 3. Now, very nicely, we can divide to both sides by that log of 5. So we have y plus 3 is equal to the log of 3 all over the log of 5. This is almost our answer. We just have to subtract the 3 to the other side. So we're just going to subtract 3. So we have this log of 3, which we can type into our calculator and divide by the log of 5, also typeable in the calculator, and minus 3, which we type that all into my calculator and get that is about negative 2.32 if we round it to the nearest hundredth. By the way, do not round any computations or intermediate computations. That means just leave it as log 3 and log 5 as we walk through this whole thing. And at the very end, we type it all in as one thing. So another example of this is where we have a little bit more difficult thing to do. We have, again, different bases on both the left. That's a 17. This is a 12. There's no way to get them the same. So we're going to apply the logarithm or the natural log to both sides. So let's just do the natural log this time. It doesn't matter which base you choose. ln is just easier. It's one less letter. So I like to do the ln, or the natural log of 17 to the 6x is equal to the natural log of 12 to the x plus 3. So we're taking the natural log of all of that. Then again, we use that power property of those to bring those in front. So we have 6x times the natural log of the 17 is equal to the x plus 3 in parentheses times the natural log of 12. Now, how do I solve this? Well, there's a few ways we can do that. I like to distribute out this. So this we can rewrite as 6x natural log of 17. That's the same. But what we can do is we can distribute this out to be x times the natural log of 12 plus 3 times the natural log of 12. We're just multiplying that out. The reason why is I'm going to move the x's to one side. So I'm going to subtract those. So if you do that, we have 6x natural log of 17 minus x natural log of 12 is equal to this 3 natural log of 12. Now, the reason why is they share x, so we can actually factor that x value out of that whole thing. So in this case, what is left is we still have a 6 and a natural log of 17, and we're subtracting the natural log of 12. So we're just saying, hey, that has an x, that has an x, take it out. Therefore, what is left is just this, and we can divide that whole side by that to get our final x value. So all we have to do is divide both sides by that weird number. So we have 3 natural log of 12 over this whole quantity of 6 natural log of 17 minus that natural log of 12. And that is what we type into our graphing calculator or random calculator. And that should give us an approximate answer of 0.514. Again, you could use log or any base log, so you could do natural log or this common logarithm of log, just log, which is on your calculator. Either one works, but ln is just less letters. So how about you try one on your own, see if you can figure this out, and then I will have an answer after you pause it and try it. So hopefully you tried it. I believe that you'll get negative 0.203. Double check that math. Again, when you divide this, make sure the whole thing is on the bottom. You sometimes, depending on how your calculator runs, is that you have to put this all in parentheses. So let's do a fun problem by using substitution. One thing to note, this is a quadratic equation. We're going to kind of factor it using some sort of substitution. The thing to notice as this equation, we can rewrite it as 3x all to the power of 2. So this part right here can be rewritten as 3x squared, and then we're going to rewrite it as minus 24 times 3 to the x, which is nice, and minus 81 is 0. And why is that useful? Well, if you just let's say u or z is equal to 3 to the x, we can substitute that in to make it look nicer. So now this is u to the second, because we're replacing 3 to the x with u, and then it's minus this 24, u minus 81 is in fact equal to 0. Now, because of that, this is a nice quadratic equation where we can in fact factor it nicely. What are the factors of 81, or negative 81, that add up to negative 24? Well, we have u, and I believe it's minus 27 and positive 3 if we have our factors. It's a little bit bigger of a number, but we can do that. And then we know that u is equal to 27, or u is equal to negative 3, in order to make that this whole side is in fact 0. Now, we don't want u, we actually want, going back to this step here, we know that u is 3 to the x. So we're going to rewrite down this as 3 to the x is equal to 27. And 3 to the x is in fact equal to negative 3. So then we will notice that this is impossible because we can't do 3 to some power to make it negative. So this is not possible. But we know this is in fact possible. So this is 3 to the x is equal to 3 to the third, or that we know that x is in fact equal to 3. And I would just double check it by plugging this back into this equation, or the one above as my original equation, to double check. Please try one very similar. I will have an answer shortly, and then we'll do our last thing together. So hopefully you tried it, you got this, you took out the e to the x, which is u or z or whatever whatever variable you want to use. Probably not an x or an e. In this case, we get u plus 6, u minus 6, which therefore this will be a negative, which will have no solution for that one, but u, or positive 2 works, so e to the x is 2. Take natural log of both sides to get the x out of the exponent, and then we get natural log of 2, which is 0.69 as that answer.